Is board is visible to everyone? Yes. Okay. For the today's session, new topic for our today's new date, that is 9/2022. It is the beginning of our September. Okay. So just start with new topic, that is Lvdt. For the mechatronics subject, Lvdt is included. Okay. Now Lvdt stands for linear variable differential transformer or transducer. I am saying here two words. Lvdt stands for linear variable differential transformer or transducer. Transformer in the sense that it uses in its construction primary and two secondary coils, and their working is based on Fleming's left hand rule and as well as right hand rule. That means Fleming's rule. So as the transformer principle used, so it is a transformer. So I am using the word Lvdt, linear variable differential transformer or transducer. Now transducer in the sense that it converts one form of energy, that is this displacement energy, it into electrical form. One form of energy get converted it into the another form, that is electrical energy form. So it is transducer. We know very well definition of transducer. Transducer is a device which converts one form of energy it into another form of energy. So it is transducer. Okay. So it is clear to you that is Lvdt means you can call it as transformer or transducer. Okay. Next, Lvdt, D for differential. Now why it is called as differential transducer? Because here in the construction, if you observe our circuit diagram, if you observe, this is AC sinusoidal which is fed to the primary coil. This is P stands for primary coil. So this is the primary coil. Okay. AC excitation is applied to it. It gets inducted, flux get induced in it, and this flux get linked because of this soft iron magnetic core in the two secondaries respectively. So secondary 1 and secondary 2, the EMF generated across the two secondaries, that is ES1 and ES2 respectively. Okay, so net output is E0 for this circuit. Further, this E0 is given to the signal conditioning unit, that means to amplify this E0 in proper fashion, and so that it is acceptable to the next stages, that is data transmission unit and data presentation unit. And finally, you can take the output for the computer also. Okay. Now here differential word meaning we are understanding here. Why it is called as differential? Differential in the sense that if you observe this these two secondary coils, secondary 1 and secondary 2, these are cross connected. Cross connected means for it not in a serial form. That means serially you can say it is like this. This is the serial form. In series, these are connected in series. What is the output of this? This will be the, suppose ES1 and ES2. This will be the output of this. It will be the ES1 plus ES2. But here the secondary coil's last end is connected to the last end of the primary one. That means cross connected. Okay. Instead of first end, starting end, suppose here this is starting end for secondary one. This is end. Okay. Or you can say end, and here starting end for secondary 2, and this is end. Now that means E is connected to the E. That is cross connected. Getting? So whatever may be the output obtained, it is differential one. That means ES1. It is cross connected means it is like this. It is shown here. So E0 will be equal to ES1 minus ES2. ES1 minus ES2. So this is called as differential transformer. What is it is called? It is called as differential transformer. So you get the basic idea about why Lvdt is called as differential transformer or transducer. These things are clear to you? Okay. Now let us move to the construction side. Now observe this diagram properly. Inside, if you observe this outer part of the outer part, that is hatched line, this is steel tube. What is that? It is steel tube. This Lvdt core is housed in a steel tube. Lvdt core is put in steel tube centrally. This is the Lvdt core. Core is put at the center of the steel tube. Inside the steel tube, there are just arrangement is made like that. Here the primary coil, that is this coil, primary coil is here at the middle. This is the primary coil. I have taken here cut section. It is cut, half cut section. So you can observe the coil. This is rounds. Right now, cut sectional way. So this is the primary coil, and these are the two secondary coils. Secondary 1, okay, and secondary 2. Assume this is round cell. Right now, circular cell. So this is the primary coil, and this is are the two secondaries. That means two secondaries are placed adjacent to the primary on either side. Getting this in the construction, it is clear. Now this core material, core is made up of soft iron core. It having the magnetic properties. Okay. So further this core is connected by this connecting rod, and it is connected to the micrometer. Now micrometer is used here as a standard device which gives the input to the Lvdt, that is displacement x. That is displacement x. As the micrometer rotated positive, that means clockwise direction, it will move in forward direction. So as it moved in forward direction, as the core is moves in forward direction, that means position will be here. Right now. So more flux get linked in secondary 1 than secondary 2. Right now. Because presence of core helps helps for more flux induction. Right now. So when it is moved in positive direction, the more flux get induced in the secondary 1 side. So we can see this in on this side. Let us consider the upward motion is positive and downward motion is negative. For the upward motion, that is clockwise rotation of the micrometer, the core will get shifted up. This is the null position. It gets shifted to the upside. So more flux get linked in here. That means the secondary for the positive displacement, the condition is that ES1 is greater than ES2. ES1 will be the greater than ES2. Why ES1? ES1 stands for electromotive force induced in the secondary 1 is greater than electromotive force induced in secondary 2. We can say here that as the ES1 is greater than ES2 and as this is a differential transformer, we get the equation output E0 will be equal to ES1 minus ES2. The output net output resulted, it is positive, which is positive for positive movement. Get it? That means forward movement. Now similarly, observe that the core is moved to the secondary side. What will happen? If it is moved, it will be here. Right? So what will happen in this case? The more flux get linked in secondary from primary 2 to secondary 2 then secondary 1. So the condition is that for the negative displacement, that is ES2 is greater than ES1. Okay? Put this condition here in the equation. E0 is equal to ES1 minus ES2. So net output resultant, that is negative. On the circuit diagram, you can observe the core will get moved in downward direction. Let us assume. So more flux get linked in ES2, electromotive force secondary 2. So ES2 is greater than ES1. Therefore, net output resultant, it will be the negative. For the downward movement, it is negative, and for upward movement, it is positive. Okay. So further, this is given to the signal conditioning unit, data transmission unit, written over the display. You can observe the readings. It is clear to you. Okay. Now third condition, if the core is at the neutral position, at the central position, what will happen? If the core is at the central position, okay, that means equal part of the core is in contact with secondary 1 and secondary 2 respectively. So equal amount of flux get linked in ES1 and ES, that is secondary 1 and secondary 2, that is ES1 equal to ES2. Here for the null position when the fluid is located at the center, it will be ES1 minus ES2, that is 0. The net output on the display, that will be the 0, that is ES1 equal to ES2. Further, here in this case circuit diagram, also we can observe if it is located at center, it is shown at the center now. So we know very well, as the number of turns on primary is equal to the total number of turns on secondary 1 plus secondary 2. Therefore, the net EMF induced in secondary 1 and secondary 2 is equal. Therefore, output is 0. Get it? So now you understand that means X displacement gets converted into the electromotive force, and output of the Lvdt is a big signal or small signal. So we have to condition it. That means set of amplifiers, rectifier and filter, that is signal conditioning units. It modifies that signal in proper form, and that proper form signal is given to the data transmission unit, and finally over the display we get the output. Or we can connect this E0 to the computer, microcontroller or any other controller, as well as we can give this output, plot this the output, or we can control this output. Okay? In this way, this Lvdt works. That is the construction working. Now, where it is used, applications. The application area of Lvdt, it is very important that in today's industrial market, or that is the today's industrial need is there for the Lvdt to measure the strain, force, pressure, and etc. Lvdt works as a primary transducer for measuring the different physical parameters, physical quantities. As a primary transducer, in some stages, it works as secondary transducer also. In pressure measurement, it works as a secondary transducer. Okay? And wherever very small amount of displacement caused by some physical parameter, to measure that displacement, Lvdt is used. For example, beam deflection. Beam deflection very, very small. Okay, to measure, just attach this core output to the Lvdt, it will measure. Right now. So in this case, very small displacement. To measure that, the Lvdt is applied. There are 1,000 number of applications are there for Lvdt. Now, what is the limitation of this Lvdt? Limitation of Lvdt is in the available market. These are the available in the range 0 to that means 30, 0 to 50 mm range, or 0 to, and that is the last range is 0 to 76 mm. And with 1 watt power consumption. This is the limitation, because beyond this we cannot construct the Lvdt. Getting this? Why? Because above the 1 watt, what will happen with these wires? We can think. Right? For the 1 watt, more than 1 watt power consumption, okay, then that means it will not work properly. It will produce the errors, or it will get overloaded or burn out. Okay, so generally it is designed for 1 watt power consumption, and that is 0 to 76 mm only. Whatever the X displacement period, it is 0 to limited to the 0 to 76 mm. That means 7.6 centimeter. Up to that means up to this level, that displacement can be measured. So it is a very sensitive equipment to measure the displacement in proper way, or in where the CNCs are there, or very accurate and precise manufacturing is needed in industry, mechanical industry. In that cases, or in different gauges also, the Lvdts are used. Okay, there are 1,000 number of applications for the Lvdt. And it is having the advantage that it is having the rushed construction, as it is mounted in steel tube. Okay, it will protect from damage and etc. That means cracks and etc. So limitation, there are certain limitations are also there. Disadvantages are also there. Okay, that is about the Lvdt. Now we will see what is the performance curve of the Lvdt. With this diagram, we can observe the performance curve of the Lvdt. On the x-axis, it is taken positive core displacement from 0 to positive side, and 0 to negative side, negative core displacement, that is x, and output axis, that is y axis, E0 is taken. Now we know very well, as just some input is fed by this micrometer to the core, it will move in forward direction. Let us consider forward direction. So output will start from initially as it is started, it will not show some readings. Okay, if it is not showing some reading, it is treated as initial drift. It is treated as initial drift. If further it is moved, then it will move up to the construction limit, up to this. But beyond this, it cannot move because of construction limitation. So it will avalanche breakdown is taking place. That will show the reading to you. Get it? Similarly, on this side also, it will move linearly and it shows like this. Now, there are certain errors in the Lvdt that can be observed or seen. That is hysteresis error, sensitivity, linearity, and resolution. Okay, that will focus after this topic. Okay, I think you understand this construction working application of Lvdt.